Hello guys, let's find the general solution for this integral right here, x to the power n minus 1 divided by x to the power 2n plus minus x to the power n. Now, here let's use the indices law first, or actually let's just start with an example and we can base it off of that. So let's choose n to be 8 so that we get x to the power 7 by x to the power 16 plus minus x to the power 8 dx. Now, instead of x to the power 16, what you can do is you can write it as x to the power, well, this 16 is just 2 into 8. And here this will be x to the power 16 equals to x to the power 8 into 2. Now, using the indices law, what we can do is we can rewrite this as x to the power 8 whole square. Because the 2 will just come down and multiply with the 8, giving us the 16 back. So this is the x to the power 8 whole square plus minus x to the power 8 by x to the power 7 dx. Now, if you watched my first video on finding the general solution, you can just do a quick substitution for x to the power 8, which would give us 8x to the power 7 dx. So we divide by 8, multiply by 8, and this numerator part will be the du. So this will be 1 by 8 du by u square plus minus u. Now, this is where it starts to get a bit difficult, because here we will get case 1 and case 2. So for this example, I'll simply choose plus. But don't worry, for the general solution part, I'll give the case for the positive and case for the negative one. So this is du by u 1 plus u. Now, you can solve this integral using the partial fraction method. So let's just find the integral for du by u 1 plus u. So this will be a by u plus b by 1 plus u. And of course du, and this will be a whole bracket. I'll just write here also. And what we want is we just want 1. That means we don't want u in the numerator. So you can calculate this on your head, but you can simply multiply it out. You'll get a plus au plus bu, which should be equals to 1, or a plus u, a plus b is equals to 0 into u plus 1. And here, see, the coefficients must be the same, so that means we must have a equals to 1, and that means that a plus b is equals to 0 right here. Therefore b is equals to minus 1. This will be equal to the constant term, this will be equals to this. So we get 1 by u minus 1 by 1 plus u du. And if you want to verify that, you can simply multiply. It will be 1 plus u minus u. U's will cancel, giving us 1 back. So this will just be ln u minus ln 1 plus u. But directly we can just write x to the power 8, x to the power 8 plus c. Now, let's quickly find a general solution. And we will use this part right here. So first, instead of this, we know that we have to just take u substitution for x to the power n. So let u equals to x to the power n du is equals to, oh wait, I forgot the 1 by 8 right here, equals to 1 by 8 like this. So du will be equals to n x to the power n minus 1 dx, n 1 by n. So we have 1 by n integration du by u square plus minus u. Now, first case 1. we choose the plus. Now we know if we choose the plus, we will get this right here, and because all of this process right here will be the same, so in fact we'll get 1 by n ln of n minus ln of 1 plus, not n, x to the power n, 1 plus x to the power n plus c. So that is the general solution when the case is positive. But what if the case was negative? So case 2 is negative. Now in both of these cases we will have to use the partial fraction method. So it will be 1 by n ln, oh wait, we have to solve the integral first. 1 by n integration du u square minus u, which is taking u common, minus u. So this will be 1 by n integration of a by u plus b by 1 minus u du du. Now looking at this, we can see a and b should be 1 because you will get 1 minus u plus u. And you can use the partial fraction method to prove that, but I'll write it right in the next step. This is 1 by u plus 1 by 1 minus u du. Therefore we get ln of u, which is x to the power n, plus ln 1 minus u, which is x to the power n, plus c. So kind of similar but a bit different. The signs of these are different. And that's it for the general solution. And if you learned something new, please like and subscribe. Thank you.